All right, Rezonent, welcome officially to our 2021 Going to Series A Investor Celebration. We have an incredible meeting planned for you today, and it is all going to start with a cocktail. So it doesn't get a whole lot better than that. I want to introduce the one and only Tony Stewart, lead mixologist and director of mixology from the Michael Mina Group. He is spectacular. He's going to take us through the magical mule. But before I turn it over to Tony, I want to make sure everybody that RSVP'd received their box and has opened it, taken out the ingredients. Hopefully you followed the directions on your agenda and you have some fun blue ice, because that's where the magic in your magical mule is coming from. So get ready to go. And without further ado, Tony, let's make a mule.
Well, thank you so much, Adam, for that lovely introduction. Just to go over really quickly, I hope you have your kits in front of you. We're just going to go over really quickly what we should have in our kits and what we should have right in front of us. I'm going to start off with the start of the party here, a little bit of Tito's handmade vodka, really great vodka made here in the United States, Texas, made 100% from corn, delicious stuff. We're going to move on to our Ina ginger shrub. This is going to be the ginger in your Moscow Mule. Really beautiful handmade shrub here in the Bay Area. I love this stuff. It goes great with every cocktail. Little Topo Chico, fantastic Mexican soda water. You should have a little pretty blue tea bag. Hopefully you planned ahead, boiled that water, and have some really beautiful blue ice to go in your drinks. A little bit of candied ginger, delicious stuff that we're going to garnish our magic mule with today, and some skewers as well, a little packet of skewers that we're going to use to put on top of the drink. So without further ado, let's go ahead and get started here. So I like to shake my cocktails at home. I think it provides for the best dilution, really great mixing for your drink. If you don't have a shaker at home, that's okay. Feel free to just kind of follow along and we can build the cocktail in the glass. But I'm going to go ahead. So go ahead and grab that Tito's handmade vodka. If you don't have a jigger at home, I believe your card should have a conversion to tablespoons. I have a jigger, so it's a 2.5 ounce here. I'm just going to go ahead and use the whole bottle. If you're going straight into the glass, no big deal. Don't be shy. We're here to have a good time nonetheless. Go ahead and shake that ginger syrup. Want to make sure we give it a good shake so there's no separation there as well. We're going to do 1.5 ounces of this, so I believe 3 tablespoons if that's what you're using at home. It smells fantastic. So like I said, I like to shake my cocktails, so I'm going to go ahead and get started here with my shaker. Make sure it's all mixed in there. Get some nice dilution there, crack it open. And if you're going in the glass, no big deal. Go ahead and get that glass in front of you. Make sure you've got some blue ice cubes in there. Like Adam said, that's where the magic is coming from in your magic mule. Open up that Topo Chico. I'm going to go right on top here, like so. And what's really cool about this blue ice is that as it dilutes, when you add bubbles or a little bit of citrus or carbonation, it's going to start to change color. So it should go from like a deep blue to like a really pretty violet. And over time, it should kind of like settle like this nice, cool bluish gray color, which is really nice. It's going to be a lot of fun. And just go ahead and pour that over, fill it up. Don't be shy. So find that candied ginger that you have sitting aside. Grab 2 pieces out with the skewer. Go ahead and stick them on there like so. And go ahead and just rest them on top like that. And you should be all set. That's your magic mule there for you. Please enjoy. Cheers.
And again, people, the magic is coming from your blue tea. Hopefully at home, you do not have big studio production lights melting your blue ice like we do here, but you should be seeing a reaction at home where you should have a wonderful, magical purple drink. We encourage you to upload photos of that magical mule right to the stream so we can see it. But without further ado, we do want to pass it back to CEO Dr. Ignatius. Now that we all have a cocktail in hand, please have your cocktail, raise your glass as we turn it over to Dr. Ignatius. Ignatius, they are all yours.
Hello, my friends and early investors, and soon some early adopters of technology as well. The two things I love about Silicon Valley are the early investors and early adopters. Okay, so we reached a milestone where we have walked the talk. We have built a chip that shows that our technology, patented technology, indeed can save 30% of the power, world's data centers, and other high energy usage. And we also shown that we can save at least 40% of heat that's dissipated by these mega chips. And even 5% is a big deal in the power industry, as a lot of marketing professionals will tell you. Right? And us making these double-digit numbers in this area is a very good future for us. And let's all toast to that. And I would like to introduce my dear friend, a real doctor, I'm only a PhD doctor, Dr. Friedlander from MIT, coming out of MIT, who has been with the company right from the beginning as a founder and a mentor and a coordinator for all the other professionals. We managed to get together here to build this company and the chip. Dr. Dean?
Thank you, Dr. Ignatius. It's been really both fun and exciting working with you for the last few years. The question comes up, how did we achieve so much? Our proprietary technology used inductors placed on the processor to harvest the wasted energy in circuits before it becomes heat. We reuse this energy within the chip to power the circuit in the chip. To prove out the success, we chose our first application carefully. We used a well-understood node and made certain we could compare the improvements using our technology with a twin set of components, the same processor without the Rezonent technology. Our results were dramatic. It showed that our technology provided significant savings over a wide range of operating frequencies and a wide range of operating temperatures. There are charts available for you to see that explain and demonstrate these results. We did all this with strict control on our costs. We successfully executed our program with an all-in cost of $1.5 million. By comparison, it costs most companies about $5 million to design and build a prototype. We did this by outsourcing our base work whenever possible to a team of engineers in India. I personally visited this team, and they share the excitement that we are demonstrating to you today. We will take this disciplined approach with our commercial development program and get more for every dollar we invest going forward. Our attention to cost control is a competitive advantage. We then took these results and selectively shared them with a group of industry insiders, ranging from design houses servicing nearly 1,000 technology firms to chip manufacturers at the leading edge of performance. Their reaction was amazement at what we have done over such a short period of time and at such a minuscule cost by their standards. Everyone we approached is a potential future customer or channel partner. We will re-engage with them when we have a turnkey application. Ignatius?
Thank you, Dr. Dean. And we chose a very deliberate path of development and prove it first, like I mentioned. No? So we actually have the silicon here. If you ever come to our Milpitas lab, I'll be happy to host you and you can actually touch our piece of silicon, because many people in the Silicon Valley have never actually touched a piece of silicon. And we are serious, and we're being seriously taken by people who do matter, like very big companies. With our test chip a huge success in the launch of our go-to-market funding, we will now raise the profile of our company a bit louder with our accomplishment. So other than early adopters and early investors, the biggest asset of Silicon Valley is the professionals, the deep technical professionals and highly skilled professionals, and those have joined us now, as you'll soon see our marketing personnel. Based on positive feedback from our targeted industry dialogues, we entered to pursue the latest technology called the 5 nanometer TSMC FinFET market, with a focus on data center applications where we can bring game-changing effects immediately. Now I'd like to introduce to someone who a lot of you may already know, again, who came in the early days of the company with Dr. Dean and helped to build the company to where it is now, Jeremy and Chuck. Jeremy?
So to do this, we'll fund our commercial launch by raising a 12.5 million Series A round. And we plan to take this down in various stages that will fund us through 4 major milestones in our development plan. One is the creation of our front-end software. 2 is the creation of our cell libraries. 3 is the development of our FinFET test development. And 4 is the completion of our EDA tool. We've already actually begun having initial dialogues with a few funding sources and are excited to get this going on as the next stage of the company. And concurrently, we're also entering some early dialogues with potential customers, which is exciting. And we hope that even those potential partnerships could lead to some alpha commercial applications with those companies.
Thanks, Jeremy. And to ready ourselves for this Series A, we are going to be closing out the existing round of investment and raising between $500,000 and $750,000 from our existing note holders, as well as new investors that we have been in dialogue with since about December. These notes offer an attractive entry compared to our next funding round and will be converted to equity along with all our existing notes as part of this next funding round. This additional capital will properly position our balance sheet for the upcoming raise and fund our operations through what we believe to be a multi-month phase. We have budgeted a meaningful amount of this money to begin our software development and to commence our business development activities. If we can attract a large corporate sponsor, it will greatly accelerate our go-to-market timeline and meaningfully enhance the value of the company. We are protecting your investment by investing in patent protection and our IP, and we'll continue to do this as we move forward. Patents are not the be-all, end-all, but they offer a base level of protection. The rest must come from keeping our methodology safe, and we know firsthand this requires vigilance and commitment. I assure you that our investors will get and deserve both.
We've been able to accomplish these milestones thanks to a group of dedicated and skilled professionals we brought to bear on this exciting program. The team that did the amazing work on our test chip stands ready to take on the next challenge, basically going to market with our product and our new technology. We have identified the leaders of each area of our development program, and we could not be more pleased with the quality of this group or their dedication to Rezonent. We've also created a very impressive group of advisors, people with the business experience and judgment to take our company to the next level. Experts in technology brand management, chip design, marketing of silicon energy management solutions, executives that have led development programs that have changed the very basis of computing. You might ask why such an illustrious group of executives would choose to join our small company. The answer is that they too see the enormous opportunity our technology makes possible. We truly are uniquely positioned to take on the carbon footprint of the digital age. We have several key advisory members. They are generally attending this meeting online, and one of them has honored us with his presence at this moment. Let me describe a little bit about each of the attending personnel. First, we have the member who is of our board who is here with us, John Benice. And why don't we shift the camera to him and he can talk about himself, whereas I'll give you a little bit about the others who are in attendance.
Come on out, John. Bring the chair. Here we go.
So John is a talent of the Silicon Valley that you can never outsource.
Thanks, Dr. Dean, Dr. Ignatius. Yes, my name is John Benice. I've been in the EDA industry for about 28 years now, working in many aspects of semiconductor design, very interested in power. I love the trend that Rezonent is on. I believe they have a solution that can really scale well into the future. I've looked at this technology. I mean, I can't say that I know everything about it, but I believe that it's a very good technology. It's been proven in 28 nanometers. I believe it'll scale well into the future in the smaller nodes and solve a huge problem in semiconductor. With Moore's law, scaling for area and for performance, it hasn't been scaling for power. So you have increasing energy density with every single node increase or decrease, I should say. And this is a problem that needs to be solved, and Rezonent is one of the most incredible ways to solve it. Thank you very much.
Thank you, John.
Thanks,
Let me
John.
just add that John knows every one of our customers directly or is one contact away from them.
Thank you, Ignatius.
So we do want to point out that we have attracted a lot of very impressive people here at Rezonent, and you can read all of their biographies, see what they're all about online. But we really want to make this about you, the investors. So we want to open up the rest of this meeting for Q&A. We do want to walk away here going into Series A full throttle. So we're going to keep all of the team members in camera, in frame, and we're going to go around and we want to do a Q&A. So if you have any questions you want to fire out, we want to see them. We want to hear from you. You can either upload them into the stream or we can spotlight you right on the Zoom. And we're going to do a lively Q&A and hopefully address all of your concerns as we approach Series A. So with that said, let's get into the Q&A.
I think we should mention three of the advisors who are attending online.
Please do.
We should mention that Allison Griffin is attending, and she is our Director of Marketing. We should mention that Loris Valenti, who is a Senior Vice President from ST Microchips, is attending, and Rob Songor, a recently retired 20-year executive at NVIDIA, who has already been talking about our product at NVIDIA, is also in attendance and is a participant. They will be available for questions once we complete, well, actually at this point, or when we are
We're
completed.
available always and right now, and the questions are pouring in. So I think, Dr. Ignatius, let's kick things off with this one directed at you.
Sure.
Has anyone adopted Rezonent's technology?
So we are in the early stage adoption. Yes, they're very interested customers. It's a long process by which this technology is adopted. It's at least 2 year to 1.5 year cycle before they make a new design chip. They're waiting for a software that makes it easy to use the technology. And we're in the process of developing that software. And that's a reason for now the early raises. Yes, we do have deep interest. We do know a lot of customers, but we don't want to go to all of them till we go through our first line of customers.
Outstanding. And I will let you guys decide who takes this one. But what is the exit strategy?
One never knows. I think the thrust has to be, though, to create a profitable company, and I believe it can, because this technology is going to be required. It's very much in demand. Power is huge right now. There's no solution like this to really give you this kind of scale in terms of power savings. And so we're obviously focused on making a business out of this and going public potentially. Any others?
Yeah.
Perfect.
I would
And
say
next,
that is one option, and there's always the first option for any company. We have very senior advisors like Rob Costgord, who are also directing us towards alternatives, maybe it might make sense to do a merger acquisition with a larger company, or maybe we'll make a technology sale. We won't close any option, but what John said is, of course, the first option.
Well, we believe that once a major microprocessor company incorporates our technology, they will have an advantage over their competitors, and that all of the microprocessor designers will want some aspect of our technology incorporated in their technology. And as a result, through licensing our technology to multiple corporations, there's an opportunity for a very large and growing business.
Next question, what is the clock speed of the chip?
Very good question. We are right now targeting for a gigahertz clock speed because that's where we show the best benefits. Somebody at 100 megahertz does not need to save so much power or heat. And 4 gigahertz is what we attempted the maximum in a given technology. So we'll go to the maximum clock speed that the processor needs. We'll try to get more speed at the same power or less power at the same speed, but we'll match whatever speed that the application needs.
Beautiful, here's one. Why can't someone else do this? Competition.
Good question. So we can do power savings of resonance in clock circuits, data circuits, and memory circuits. A lot of people, including IBM, are doing some power saving in the clock circuits, but they all have given up or said it's not possible to do this for data and memory circuits. We have shown we can do for all the three. Yeah, someone may do part of what we're doing, but no one can do everything we can do across the board, across all frequencies.
We also have blocking patents. And as I understand, IBM tried to do something similar and was not granted the patent for what we've done.
Exactly. We went against IBM on some of the patents, and we were awarded that ours is more distinct. It does more than what IBM patents do. Yeah,
That's right.
Multiple parts, but patents are important. And who ran the measurements?
we have in-house measurements done and also third-party university measurements done using standard equipment. And papers were published by a university in Baltimore showing the test results of power savings.
I would add to that, this wasn't just a simulation, this was actual chip in silicon that was tested. So we know the results are very accurate.
Outstanding. Well, John, I'm glad you're on the mic because this one is directed to you. How will you secure customers? What's the plan for market?
Well, I think, up until now, really, I think the company's really been focused on proving the technology. And now that it's been proven, I think it's going to be much easier, obviously, to get customers to sign up because we've already proven that we can do it in 28 nanometer. I can have Ignatius say why he feels that it's going to scale well at FinFET, but it should scale very well at FinFET. And I know Ignatius believes that at 7 nanometer, 5 nanometer, we can be super successful. I think once we get the word out and we're focused on that now, we're going to have a lot of interest from customers, and we'll be engaging with many customers.
You might have answered the next question as well, which is what are the applications?
So the applications are broad, but I think the biggest application is probably data center, where a ton of energy, I think it's estimated that 20-25% of all the energy used in this country by 2025 is going to be from data centers. So obviously there's a huge need for power reduction due to and air conditioning that's costing lots of money for these data centers. But it can also be used in other applications like networking, mobile cellular. All these applications are hungry for power savings.
We might want Rob Songor to tune in to answer the question about the interest of potential customers, if that's technically possible.
Yeah, Rob, if you're out there and ready, we can bring you in, but we have one directed for Chuck. Chuck, what is your burn rate and what multiple is it increasing?
So the current burn rate of the company has been brought down to basically a skeleton crew. What we plan on doing with the rest of the funds moving into the Series A is to fund our software development program, as well as the marketing of our Series A, as well as our business development outreach. That's going to burn about $50,000 a month. And we are pretty confident that we will be able to get our Series A done by end of Q3 2021.
And let's keep rolling on that note. What has been done with the investment so far?
So to date, obviously, we've been able to create a test chip for $1.5 million, which is pretty much unheard of in the Silicon Valley. We've been able to validate our test results and begin our software development as well. We feel that we've been very practical and frugal with the money we've raised so far, and will continue to do so.
Thank you, Chuck. We're going to go back to Ignatius. Ignatius, why did you select 28 nanometer as the test bed application? And is this viable to market?
The 28 nanometer is still used a lot. It is the last two-dimensional node. After that, it goes into FinFET, which is extremely expensive. Simple answer would be that is all we could afford with the investments we had. But a better answer would be using 28 nanometer, we could show how we got performance that's as good as being on a FinFET, which would be more expensive. So it is an illustrative process. That is the best we could do since we didn't have those funds for the FinFET directly at that point in time.
But we should say that part of the Series A, one of the main components is to build a 5 nanometer prototype, which is the node that will be used 2 years from now.
Correct, which is 20 times more expensive. So we didn't want to take a risk on that level of money with the early investment. We wanted to prove it out enough and have someone else pay for the next round.
Yes, and now that we've proven it, we're counting on all of you out there to help us with the next step.
Final step. On the note of Series A, Jeremy, why don't you field this one? What is the timeline for Series A, and have you talked to any Series A investors yet?
We have, and the timeline for getting that started is shortly after the close of this, which hopefully is very soon. And it should be, I would say, within the next 2 weeks. We're looking to probably sign up the last little bit of notes from any last interest that we can generate through this. So if you're interested, let us know. And following the signing of those notes, funding within 30 days from that, we'll be going, which we're excited to go out to market with this. And we have had a couple initial discussions that have gone really well. We have been focused on building the development plan, the model. We've been also focused on bringing on our advisory board and laying the groundwork for all of that. So I think that we're just waiting to close this down and ready to go within the next probably 30 days. We'll be having serious conversations on Series A round raise.
Outstanding. And we are going to patch in one of the most exciting developments in recent Rezonent history, Rob Songer. We're going to patch him in, and he's going to tell you a little bit about his perspective on it. Rob, how you doing?
It's Mary.
Hi, everybody. Can you hear me?
Yes.
We can
All
hear
right.
you.
We hear you fine.
I've achieved the first technical hurdle of being at Rezonent. Hey, hi, everybody.
Hi, Mary.
Let me introduce myself. I'm Rob Chonger. I think I was described as being recently retired. This is true. I've been close to 40 years in high tech, and most of that time I spent at NVIDIA. So I was introduced to Ignatius and the team at Rezonent through a neighbor, Brian Krebs, and I can, if it's useful, I'll give you my perspective on why I'm interested in Rezonent and why I'm here. I'm the customer. I worked at NVIDIA. I asked all the questions that I would ask if I was at NVIDIA still. The first question I asked is why don't you have a customer? Where is your customer? What's, is anybody, well, how come I haven't ever heard of you? These are all the tough questions that any investor would ask. what value do you add? I mean, power is a huge industry. You know, power management and efficiency wasn't invented by Rezonent. NVIDIA has thousands of engineers working on power. So what's unique about you guys? Okay, now I was reasonably obnoxious about asking my questions, and Ignatius and the team were very straightforward in answering. So the bottom line is this. I believe that the market conditions right now are very simple. We're in the middle of a fourth industrial revolution. We just don't realize it. The headlines are all about COVID, but we're in the middle of an industrial revolution. Artificial intelligence, robotics, machine learning is taking over everything we do, everything you do at home. Your Alexa, I mean, it's being run by a massive data center that's running tens of thousands of applications, and the processing needs are just growing exponentially, far greater than Moore's Law. Moore's Law is what used to dictate the process and the evolution of processing requirements in the market. Well, the markets have just gone way beyond that. And one of the byproducts of this is a big problem called power. Now, everybody is working on power. Power is not just about your cell phone and how long the battery lasts. It's about the data center and how much electricity you're chewing up and how much heat your data center can take. In fact, every single processing platform I can think of has power as an issue. So the question is, well, what can Rezonent do? What's unique? What's different? What's special about Rezonent that somebody else can't do? And if I was at NVIDIA, you know that we could just fire the money cannon and just go hire 1,000 people and just go work on exactly what Rezonent's doing. So why would we consider partnering with Rezonent? Well, as you can imagine, right? I think any good successful technology startup has got to focus on a couple fundamental things. Number one, pick a problem that's really hard. Well, this is really hard. Trust me. When you're talking about power on microprocessors and GPUs and CPUs, you're talking about deep magic stuff. Once you get past the simple, easy things you can do to manage power, like voltage scaling and clock gating and all of the things that everybody's already doing. But what Rezonent's doing is a couple of unique things, right? And putting inductors on chips is not unique. However, doing it across variable frequencies and doing it not just on the clock, but also on data and memory, that's actually secret. That's actually unique sauce. The next step is, well, this looks really good on a PowerPoint slide. So, what have you done? Have you done anything real? Well, the test chip is a good first step, and it's a great accomplishment. And Ignatius showed it to me this afternoon. I stopped by, and he showed me 40% power reduction across variable frequencies, and that's impressive. And you have to show it as a before and after, right? If you're talking to a customer, you can't just wave your hands and do it. You have to be able to show this is the chip before, and this is the chip with Rezonent, right? And so 40%. It's a very simple looking demo. In fact, it's not, at NVIDIA, we did special demos with 3D graphics and special effects. This demo is really just a power meter. And it just shows the same chip, one with, one without, and it runs 40% faster. Well, if you're in the power business, this is really exciting. Now, if I was at NVIDIA, I'd be skeptical still. And I would say, well, you know what? That's really interesting, but we can't run the risk of implementing this ourselves, and we can't run the risk of delaying our time to market on a product, putting some custom engineering from a startup company that we don't know. Okay, so the second part, I think, of Rezonent's secret sauce is that they're developing the software to put it into tools that all these guys use every day. So you could use software tools that are available off the shelf. And this is where the experience of people like John comes in, because he's familiar with it. He works at tool companies like Synopsys. And as a result of doing this, you could do these things and do it as part of your natural flow. So I'm kind of rambling, guys, and I apologize, but I want to give you a little bit of the background of the questions that I asked before I came on board. And I think in early conversations, at least, with some of the people I talked to at NVIDIA, just to check this technology out, I think there's great potential. There's a lot of details. There's a lot of work to be done, a lot of details to go through, but so what? That's just life, right? There's nothing wrong with hard work, and there's nothing wrong with, sweating the details. And with any luck, this is hard to do. I hope it's really hard to do, because if it's not, then anybody can do it. And if anybody can do it, it just commoditizes the whole thing. What you need is some good technology. Ideally, you have some strong patents. And I believe, at least on a surface level, I think that Rezonent has that. And then most importantly, you need a good team and you need a good leader. I think Ignatius is an expert, and I think the team is a good team. And I can't wait to see what they do.
Thank you so much, Rob. Appreciate you jumping on. And just for the viewing audience out there, all day today at Rezonent headquarters, we've been filming promo material, talking about the project, introducing all the different advisors and people that have been attracted. You'll get email updates with those videos as they come out. But at this time, we want to turn it over to another member of the team. Loris, are you out there? Can we get Loris up on the screen?
Yes, I'm here. Can you hear me?
Hey, Loris, how you doing?
Yeah. Great, thank you. I'm sorry I cannot be there with you.
It's okay. It's our fault. We're glad that we got you how we got you. So
yeah.
Go ahead, tell the world a little bit about yourself, Loris.
Yeah, so, well, let me introduce myself. So my name is Loris Valenti. I'm based in Santa Clara in California. I'm currently Vice President at ST Microelectronics. I'm the responsible for the microcontroller and digital products at ST. I spent almost 25 years in my career dealing with digital products. Half of my career was in the design, so battling against problems of power, designing complex products, and then the remaining part is more on dealing with customers, business, and so on. So let me put a different perspective here. Let's say when we look at the world today is becoming more and more complex, and it becomes more and more connected. I mean, never like today in this period of times, we have seen the need of connectivity, of being connected to the others, and the complexity of what things, what is happening today. So connectivity and complexity in our business, in our semiconductor industry, translate in the need to elaborate more data and to transfer more data or transfer them faster. So this is achieved by putting more functionalities into a chip, into a single die. And the end result of this is that, or the challenge of this, is to do it without exceeding power consumption. There is a limit in the amount of power that you can put in a single chip per, let's say, per unit of area, per square millimeter. Otherwise, the chip melts. I mean, it becomes so hot that in the end it melts. And as Rob was saying, there are multiple techniques that are being used, clock gating, voltage frequency scaling, and so on. But let's say this is the easy part, the easy way of doing it. If you want really to attack the way of doing it, you need to go deeper. And this is what impressed me when I started learning about Rezonent. Actually, my friend Dr. Freelander introduced me to Rezonent, and I was impressed by the fact that he told me, you know, there is a company that is able to recycle energy in a chip. So this was the first time I heard about the ability to recycle energy in a chip. I think this was the keyword that really attracted me. And together with this, when I looked a little bit more into the technology, I found that Ignatius and his team were able to make this technology scalable and easily portable across multiple process technology. This is key because our customer, all the companies have roadmaps of products so that needs to be ported from one technology node to the other. So the IP that Rezonent has is easily portable in different technology nodes. And the other thing is that it is scalable. So you can use it in data, in clock, in memories, and you can size it in such a way that you can tune the amount of power you want to save against let's say, the effort you want to put into the design. So I think overall this was really impressive to me, and I think this is a technology that will be really a game changer for the semiconductor industry. We have never seen something like this today, and again, you can attack the problem from the simple side with software solution, with let's say simple solution, but here we are talking about going in way deeper in the core of the problem, and I think this is what is really the key advantage of this technology.
Loris, thank you so much. Appreciate you zooming in there. We're going to go back to you, Ignatius. We've got to catch up on a couple questions before we close out.
Okay.
They want to know, how quickly can a chip be respun with Rezonent? Is it a major redesign?
We talked about earlier, typically this SOICs or chips on take around 18 months to 2 years. We have to throw more people at it. So it should not take the same amount of time as normally it does, but you have to put more resources into the development cycle. Okay. So, but the additional number of man months we have to put to use Rezonent technology would be something like 3 man months, but that can go in parallel.
So I think they're asking about the total time it would take if we acquire the resources and the number of people to do it as quickly as we can.
Okay, so to give any node, on any given node, 5 nanometer, 3 nanometer, it will take us 14 weeks to deliver a new set of libraries that people can use.
Right, and they would then incorporate our libraries into their existing design.
Design cycle.
So assuming that they already have a microprocessor for which they have customers lined up,
right,
it would add about 14 weeks if we had a number of engineers working on it to apply our library to their existing design. Is that right?
So if they already have a microprocessor that has already been designed on a node and the design is finished, and as an afterthought, they want to add our technology to it, it would take 3 man months. So if you put 2 people, 3 people on that, it may take 1 month. But if they are going to do a new design altogether, which by itself takes 18 months or 2 years,
yes,
then again, we would be adding 3 man months in parallel to that.
In parallel, so it wouldn't slow them down.
Same design time. It doesn't stretch their cycles.
Time. No extra time.
Exactly. It won't stretch a cycle.
If we get in on the beginning of their design.
At the beginning of the project, yeah.
Okay.
You would put more people on it, but it's not it can be done in parallel, the flow.
So what you're saying then is that we're not really changing the functionality.
No, exactly.
We're
Exactly, yeah.
embedding the technology.
Outstanding. We're going to go back to the finance desk over here with Jeremy and Chuck. Chuck, this one's for you. What are the terms of this final 500 to 750 note, and when will you close it?
Yeah, good question. And I see Craig asked a question as well about how much money has been raised so far. I'll answer that quickly. That was $1.4 million has been raised to date. The terms of the final $500,000 to $750,000 are the same terms as our tranche 2 note investors. That is a $7.5 million valuation cap, and it will convert at the equity financing into the same equity as the Series A. So what are we targeting for terms for Series A? Our targeted terms for the Series A, it's going to be a $12.5 million raise at a $25 million pre-money valuation, meaning that the Series A investor will own 33% of the company, fully diluted.
Outstanding. So you mentioned 1.4 raised thus far. what is the remainder of this note going to?
So the remaining money that we're going to be raising in this note was originally intended to be $2.5 million maximum. So the initial or the extra $750,000 is going to be used for increasing our software development timeline, starting up our business development ramp up, as well as helping us market our Series A. Again, the burn rate for that is somewhere around $55,000 to $60,000. And we expect to have our Series A done sometime in late Q3, Q4 of 2021.
Very good. Well, we are caught up on the questions. We want to again direct everyone back to the login if you want to read up on any of the team members here on Rezonent, learn anything about the presentation that you heard, see the white paper, the one pager. There is a wealth of knowledge, but really, we do want to leave today's meeting going full-fledged into Series A. So if you want to help close out this note, we are going to take that right now. Chuck, what's the best way for them to reach you on the note? And how will people know when we're there? Because I know we're getting kind of close just with the people that have already chimed in and pledged so far.
Sure. Yeah, I would say the best way to reach me would be at the email address where you received most of the notifications for this event from. That's rezcorp@res1t.com. You can also reach out to Jeremy Klein, and there's some other contact information on our website. But I would say the email that was telling you about the event would be the best to respond to.
And I think just for full transparency, I'm going to point this out. So far on today's meeting, we're at 375. So we are at 375 right now. Anyone else out there that wants to chime in, please do chime in. Again, the goal is to walk out of here charging into Series A. You don't have to put it publicly here, but go ahead and message Chuck direct. If you have any questions, that same email is perfect for that. You can get a hold of absolutely anyone here at the Rezonent team, as everyone's information will be public now. And Charles and Dr. Ignatius are both 24/7 with this. So we want to thank everyone for coming out. Hopefully you enjoyed the magical mules. If there are any final questions, please put them in. But I would like to end with CEO and founder, Dr. Ignatius. One final thought, one final note. Anything we didn't touch on that you would like to bring up, or any of the gentlemen in studio?
Go ahead. Dr. Dean.
I can, if you want, I can start if you want. Go ahead.
Go ahead, John. I'll end it. No,
I just
Go
want to
ahead.
say this
Say
is
something.
this has been a great event. First of all, thank you, Adam. It's been excellent. Obviously, you can see all the interest in the company. It's tremendous technology. Very excited about the future. Looking forward to helping this team succeed.
I just want to say that I appreciate everything this team has done, the people who worked so hard for a couple of years up until this moment. And I appreciate everyone in attendance, investors and other interested parties. And I hope you all enjoyed it as much as we have. Ignatius?
sure. I want to thank you for your support in this very difficult technology and bringing it to market. If anyone can do that, it's with the help of Rob himself, who is a marketeer, and John, who is a sales, who is selling into this current market. And a high level of confidence, more than when we started, that the next phase of productizing and getting to volume sales on this will be successful. So I want to thank you for your interest. Again, the three things I love about the Valley: early investors, early adopters, which Rob is trying to get us, and then of course the best-in-class professionals like John, Allison, and Adam, of course. So I think we have a wonderful future ahead.
And that is going to conclude today's meeting. If you have any follow-up questions, do email us. Check out the links. Go to the website. We want to hear from you. Stay active. And remember, there are some great testimonial videos from all of the team members coming to you soon, as well as a commercial spot that you're going to want to check out. So thank you for coming out. Greetings from Rezonent Corporation, and thank you for being part of the team. Good night.